Dear students, in this module, we are going to study about the principles of green chemistry and the bromination of trans-Stilbene. I am Dr. M. Tamim Ansari, Assistant Professor of Chemistry, Sadakatulapa College, Tirunelveli, Tamil Nadu. Chemistry is an inevitable part of our life. Chemical processes also bring a new environmental problems and harmful and unexpected side effects. For example, pesticides are used in the agriculture to enhance the formation of products. The products cultivated by using pesticides giving harmful side effect to the human health. So green chemistry looks at pollution prevention on the molecular level as well as larger scale level, and it is an extremely important area of chemistry due to the impacts of chemistry in our world today. So we can define the green chemistry uh, by giving a quote. It is an invention, design, development, and application of chemical products and processes to reduce or to eliminate the use and the generation of substances hazardous to human health and environment. There are 12 principles govern the green chemistry. First one is prevention of waste. It is better to waste. It is better to prevent waste than to treat or clean up waste after it is formed. Number two, atom economy. Synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. Third one is less hazardous synthesis. Wherever practicable, synthetic methodologies should be designed to use and generate substances that possess little or no toxicity to human health and environment. Number 4. Design benign chemicals. Chemical product should be designed to preserve efficacy of function while reducing toxicity. Number 5. Benign solvents and auxiliaries. The use of auxiliary substances such as solvents, separation agents should be made unnecessary wherever possible and innocuous when used. Number 6. Design for energy efficiency. So, energy requirements should be recognized for their environmental and economic impacts and should be minimized. Synthetic methods should be conducted at ambient temperature and pressure. Number 7. Use of renewable feedstocks. A raw material feedstock should be renewable rather than depleting whenever technically and economically practical. Number 8. Reduce derivatives. Unnecessary derivations, blocking group, protection, deprotection, temporary modification of physical and chemical process should be avoided whenever possible. Number 9. Catalyst for selective synthesis. Catalytic reagents as selective as possible or superior to stoichiometric reagents. Number 10. Design for degradation. Chemical products should be designed so that at the end of their function they do not persist in the environment and they break down into innocuous degradation products. Number 11. The real time analysis for pollution prevention. Analytical methodologies need to be further developed to allow for real time in process monitoring and control prior to the formation of hazardous substances. Number 12. Inherently benign chemistry for accident prevention. Substances and the forms of substance used in chemical reaction should be chosen so as to minimize the potential of chemical accidents, including releases, explosions, and fires. So these are all 12 principles governing the green chemistry. Now we will move to the uh, topic for bromination of trans-Stilbene. How we can prepare, how we can execute bromination of trans-Stilbene through green chemical approach. So in this green chemical approach for the bromination of trans-Stilbene executed by using the chemicals such as trans-Stilbene is able to take 1.8 gram and hydrogen bromide in water about 5.2 ml, hydrogen peroxide about 7 ml, and ethanol 10 ml. The trans-Stilbene about 1.8 gram is dissolved in ethanol and it was refluxed in the condenser. The aqueous solution of hydrogen bromide about 33 percentage and hydrogen peroxide uh, were added from a dropping funnel sequentially to this reflection solution. To this reflection solution of Stilbene. The colorless solution became a deep orange in color. Within 15 minutes, the orange color disappeared. This indicates the bromination of trans-Stilbene. The solution was allowed to cool down. During this, the precipitate due to the Stilbene dibromine separated out. The precipitate was filtered and recrystallized and dried. There are one more method to adopt a bromination of trans-Stilbene in green chemical approach because the previous one requires high temperature, but here we have to use some glacial lactic acid to give energy conservation. So in this method, we are taking sodium bromide, bromate mixture as a bromine source, and then glacial acetic acid about 20 ml and trans-Stilbene about 1.8 gram. So how we can do bromination of trans-Stilbene by this method? To a solution of trans-Stilbene in acetic acid, so we have to dissolve a trans-Stilbene in acetic acid about 20 ml, and then it was added with the sodium bromate mixture at a normal room temperature by stirring a glass rod occasionally. The reaction mixture was then stirred with a glass rod about for 1 hour. The developed light brown color disappeared. It shows the bromination of trans-Stilbene is executed. The acetic acid in the reaction mixture was then neutralized by the addition of sodium hydroxide solution. The precipitate of Stilbene dibromide separated out, and this was filtered and dried. So, what are the green context in this bromination of trans-Stilbene? So, here we are using uh, sodium bromate mixture to avoid corrosive liquid bromine. And second one is this atom efficiency. So we are getting nearly 80% as a product. And third one is water is the only byproduct in the HBr hydrogen peroxide method and in bromate mixture. So we are getting a water as a byproduct rather than some getting harmful byproducts. So this one is also important. Green context. And fourth one is hydrogen peroxide mixture, and a bromine bromate couple offer in situ oxidation of bromine to the molecular trans-Stilbene. Thank you.